So now today we are looking for the topic, very interesting topic, that is about vector machine. What are the various points that are required to be covered over here and point to be discussed today? Those are why support vector machine and what is the support vector machine, that is we have the SVM and understanding support vector machine. Before telling anything about the support vector machine, just let me know the student size. Do you have any idea about the support vector machine, or anyone who is working on the support vector machine? Just let me know the status right now. Anyone who is just familiar about this term or who is working, just please let me know. Anyone?
No, sir.
Okay, good. So no problem, no problem. So I'm here, so I will tell you each and everything from the scratch mode so you can understand properly. So what are the points which are required to be discussed over here? That is the why support vector machine, what is support vector machine, and understanding support vector machine. Let me give some little bit idea about the what is mean by the machine learning. So and what is mean by the machine learning? Machine learning means we have a concept in which we need to understand how machine will learn and what are the various criteria by which machine will able to learn, and those are recognized by the its learning criteria or learning techniques. So we have the three important learning techniques. Those are supervised learning, unsupervised, and reinforcement learning. Supervised learning, as we know, the where the information will be followed by the guided pattern. But when talking about the unguided pattern, then we have the unsupervised learning. And if you remember the diagram where it was mentioned over there in supervised learning, we have the two type of the data by which we will understand which algorithm is required to solve this problem. Just like example of the categorical data, continuous data. So when we have the continuous data information, then we have the linear regression, polynomial. Okay, we have seen this information, and we have seen the decentralization. But when talking about the classification based data, or we can say the categorical data, so we have the classification technique, and we have also covered logistic regression. And after the logistic regression, we have the support vector machine, and the support vector machine mostly used for the classification. But frankly speaking, this is the tool which is applicable for the classification as well the regression. Because of final, you can understand after classify your data what you are expecting. You need to predict something. So definitely the regression will be implicitly usable by the classification approaches like the logistic. In the logistic, we are using the classified the data, or we are working on the category based data, but finally we are predicting something. Same in the SVM, that is support vector machine, we will use the classified based data or category data, but we need to predict something, and we need to predict the new data is belong to this class or this class. This class one or class two. Suppose we have the two classes. So from this point, we need to understand the support vector machine. And unsupervised learning, of course, we have the so many examples. So we know the supervised learning, what is mean by supervised learning. And as far as the technique is concerned, or about the supervised learning, we will discuss when we discuss about the unsupervised learning in detail manner. Reinforcement learning, as you know, it is mostly used for the gaming purpose. So I will tell you more and more detail about the reinforcement learning in proper way. So right now I'm just back to my supervised learning approach, where you can see the slide, and in which the point is written over here. Supervised learning basically saying to us, we are talking about any machine learning model. And in the machine learning model, we try to learn from the past input data, that is experiences, we can say, and make future prediction as an output. So if by using any data set, I'm just trying to teach my model or training my model. So after training my model, if I'm giving any input, and if as per the according to the trained model, if I'm giving the any new input, so maybe that is what I'm new. So at that time I'm putting a new input. At that time I'm just predicting, is it matching, it is matching with our information or not. If it is matching with our information as per our desired feature, so we can say we got the our result. So my model is trained. So according to trained model, we are getting something. But what you are talking about, past input data. Past input data means you are talking about the previous or experience data, and that is defined the label data. It means we are talking about the supervised learning. So past input data, we will do something here into the supervised learning. So definitely we have some supervised. All these concepts we have seen properly on supervised learning approaches. From this point, we need to start where SVM plays. Okay, so you can see the SVM always plays in the supervised learning approach. And now when we use a support vector machine, or we can say the SVM, it supports both kind of the approaches, that is the classification. If I'm saying the classification, then it contains by the, or it is having by the category kind of the data. But when talking about the regression, then it is having by the continuous kind of the data. So support vector machine will be used for the classification purpose. So just like the logistic regression approach, it is also used for the classification. It is used for the classification problem solving approach. When unsupervised learning and irreversible learning, we will discuss time to time. So, but now let us start the support vector machine. Till now, you have any doubt, then you can ask me right now. Yes, please tell me any problem right now you are having. Please, you can ask me right now. Student, tell me any problem.
No, sir.
See, one thing I'm just remembering right now, then I can explain in very well manner. See, in the regression, what we have seen in the regression, we need to use a dependent variable, independent variable, and both informations contained by the continuous method. But when talking about the classification, you have to use the classified data, or we can say categorical data, where you need to define where if you're putting the new data, so in which class the particular or the new inputted data will belong. That is objective. So finally, what you are doing, you are doing the two activities inside the any classification algorithm, like classify the data, and you need to predict in which class the new input data belong to. So that's why it is written over here the regression. So SVM logic regression internally support by the prediction as well after the classification approach. After understanding this point, we have a question: why SVM or why support vector machine? Now, I'm going to start this lecture by a very simple example. Then you can understand. In the last week or the last month, suppose you can say, my son and I visited a fruit shop. And my son is asking me that is that an apple or a strawberry? Now, this is a big question my son has. And now, right now, if he has or if he had, at a time I need to plan what should I say. So from my past experience, I know is it strawberry, and then I'm guiding to him this is strawberry. He will be happy to know the information now this is strawberry. But next time I will show this is strawberry or just apple, definitely he will easily recognize. So what I'm doing right now, I'm just training my son, or just like example of training my model. The same thing, if I'm training my son, this is the apple or this is the strawberry or this is a different kind of the food. So we can say, or my son easily say, if I'm putting the new information to my son, if I'm showing the new or different kind of the food, so he can easily determine is it a strawberry or is it an apple or maybe the different kind of food. So there he found a fruit shop where a fruit which was similar to both color, we can say. So apple strawberry almost belong to the red color. So definitely at the time the my son will get confused. So by choosing some features, I will explain to him, now my dear student or my dear son, this is a strawberry and it contains different features. And that is a little bit different here has to keep in mind. So from this point, we need to start the part. Now, after understanding this concept, at the time what I am following practically, I am following the supervised learning approach to my son. So after a couple of the seconds or a couple of the minutes, maybe of course, depend on the capability of the gaining or grasping power, my son easily could figure out that it was a strawberry. So definitely what he observed, according to my opinion, according to my words, my son is easily predicting the information that is it is a strawberry or it is an apple. So what I'm doing right now, I'm following the supervised learning. Okay, that is my point. But why I should not build which can predict the unknown data? So as a each and every time, suppose I'm not with my son, then now when my son is visiting any market and he found a new fruit, and then he will get confused, is it strawberry or apple or different kind of fruit? Because according to new data, according to just like the mango or different kinds of fruits, just like the grape, my son was not trained. So definitely I need to train to him just like a building a model into the machine learning. So same thing we can say over here in the supervised learning. What I need to do, I need to build a model to my son helping purpose, and to predict the unknown data. Is it a strawberry or is it an apple? So you can see over the image here, there is a two fruits we have over here, apple and strawberry. And that is known as the pass level data, or that is the recognized information we have over here. So new input I am putting into the black strawberry. You can observe over here. So what you can observe over here, based on the features, this object will be identified. So what is the feature I am choosing here to explain or to build my model? Of course, that is the size and shape of the fruit rather than the color. That is the point you need to keep in mind. And this structure or the size and shape of this object or new input data, that is similar to the strawberry you can observe over here. So what are the very steps? One is the model training and prediction and output we have. So this is strawberry. We can easily see. So if I'm putting the new unknown data to the my machine or to the my son, okay, if suppose just like a black strawberry I'm, I'm giving to the my son. So he always say it's a strawberry because on the basis of the size and shape, I have trained to him. That is important. Now, this image is visible to all, or you are getting something here. You have any doubt, then you can ask me right now. Yes, tell me. This till now everything is clear, or you have any doubt? Please, you can ask me right now. Just to tell me.
Clear, sir.
Clear?
Clear, sir.
Okay, good. So I'm repeating once again the statement. The model is trained by the based on the some features. Those are the size and shape rather than the color. Okay, so that is the point we need to. So this is a support vector machine. So support vector machine work like this one. Okay. So what you are doing, you are classifying the data based on the some features, and based on this feature, you are classifying your information into the class. So suppose we have the two class, one is belong to the strawberry class, other belong to the apple class. So from the this new input data based on the different features, we can easily recognize what kind of the fruit we have. So this is the working of the support vector machine look like this one. But this is a normal working of the supervised learning. But this is not an end of the support vector machine. Okay, so that is my point. So finally, what you are observing over here, support vector machine is a supervised learning method, and that looks the data and sort it into one of the two categories. Those are definitely, so if you're saying the two categories, it means I'm talking about right now the binary classifications where it contains the 0, 1, true, false, or yes or no, or maybe two different values. So here we have the two different values. Those are belong to the strawberry and apple. Okay, so this is the point. After understanding this point, again we have a question. But how does the prediction work? Is the question we have in our mind. So how does the prediction work? That is still question behind our mind. Let us understand this concept as an example, then you can understand. Now we are now known to this SVM idea, how SVM is required or how SVM is. So why SVM is required? So we're understanding this point. SVM. SVM name as a suggesting support vector machine, and why it is given by the name SVM, that is support vector machine. So I will tell you. But let us understand some fundamental part of the SVM over here. So what we have over here at the initial level, we have the some sample data in form of the label. Why label? Because it is a part of the, or it is an example of the supervised learning. I will classify my data into two different parts following by the boundary. So that is known as decision boundary. And this decision boundary is recognized as a hyperplane, okay, in a graph. Whenever we need to filter two information, then how we can filter by using the hyperplane in the mathematically. So this is just like equal to descent boundary. Okay, that is the point you need to keep in mind. When I'm putting the new data of the fruit, that is the unlabeled data, of course, because that data is not guided. That is the new data, could be anything, just like any fruit, could be a mango, could be grape, could be any other different kind of fruit. So if I'm putting here at this level, when I'm plotting the new data, so my model will predict the unknown data. And after manipulating the data, my model will give the information, or my model will classify these two new inputted values into its respectively groups, and those are known as the cluster. Because we have, but we will not talk about the cluster. But here we'll talk about only the groups or the classified data, that is known as the classes. So here the data, input data will be classified into two different classes. One is the apple class, other one is the strawberry class. So now you can see over here, the apple will go into the apple group or apple class. Why? Because its feature of matching with the apple. Same thing will be done by the strawberry. So this prediction will look like very simple how we are doing. The prediction means based on the new inputted data, some features are matched, and based on the features, we are getting the value very close to the one in terms of probability. So we will say we have the this fruit, or we are matching the new inputted fruit with our data set. So as according to data set, we are put into the respectively classes. So this is the point, just idea about how supervised learning play important role to deal with the SVM. But so far SVM is not started, very frankly speaking. Here we have seen just connection between the SVM and supervised learning. Yes. Tell me any doubt here right now. Tell me any doubt here you have. Please ask me. Else I can start the SVM. Why SVM is required? Okay. So what is the SVM? Why SVM is required? We have seen because SVM is required because of it is a supervised learning in which we need to classify the data based on its trained model. The prediction will be done by the its trained model. Okay. So now tell me any doubt you have. Please, you can ask me right now. Just tell me any doubt, student.
No, sir.
Okay, so now next we have. Yes, tell me. Okay, so we have an important part over here that is saying to us what is a support vector machine. So that is a big question we have to discuss. What is a support vector machine and what is a SB? Let us understand this problem by the two different features, or it is a simple example following by the two different features. One is the height and weight. So we are given a set of the people with different height and weights. Okay, that is a point you have to keep in mind. Here I have some sample data. This data can be recognized by the classified data. So what are the features we have on which we can use our data? So we have the two important features. One is the height and weight. And we have the two different classes in which the information will be stored. Those are the female and male. Okay. So maybe if we're talking about the one data set followed by the female and male data set, of course, the all data, these two values of the height and weight, respectively male and female, will be integrated or combined. But here we have the classified the data over here to solve our problem. Okay. The features are height and weight, and class will be male and female. So what are the male and female? These could be identified by the our as an important aspect on which we will do understand what is the height and weight. So based on the features, we can easily determine if we are putting something new to determine is it female or male. Now, this is the point. Let me know right now. This image is visible to all. This image is visible to all.
Yes, sir.
Yes.
Okay. Okay. So do some. Yeah, okay. So do some amendment over here now. Just for more clarification. This is not a value of the height. This is not value of the weight. See, this is a value of the height. Okay. And this is a value of the weight. Please keep in mind. It is wrong. Drawn over here. You can observe over here from the data set, which was mentioned over here, that is the height and weight. So if you're talking about the female, we have the height female ranges from the 174 to 185. Okay, and the weight says 65 to 80. You can observe over here, 88 is maximum. Okay, so if we're talking about the weights, so we have the weights over here. So this would be maximum 88. Okay, so I can, for understanding, I can assume just like this one. So this would be our 88 maximum. 1, 2, 3, 4, 5, 6. So we have the 6 information, but we have the only the 5 information. So example we are taking, but plotting is different way. Same we talking about the male, and last value is not displaying due to not due to just remove. It is removed actually. So we are taking right now for understanding the 5 different values, but we are having the information on our graph for the 6 information. Now when talking about the male, so height is 179, 180, 183, 172, and 182. So starting from the 179 to 187 maximum. And weight is 72, 85, 80, and 90. So initial weight is 72. So we have the this point. The person who have the weight 90 kg, of course, and his height is approximate around 179. Okay, so it height could be around 179. So we can assume it has. So the our graph look like this one. So I'm taking this graph because we have lots of the graph for explaining purpose. So that's why I'm taking this example for understanding purpose only. So here our information is classified into two way. One is the male and female. Okay. After understanding this point, after knowing to this point, if we're adding a new information, so we can say the new data belong to the which class. But this is the not the end of the SVM. SVM is saying to us, if you have your information, then you must have the information to two groups. So here we can observe, easily observe here, this is a kind of the one class group, and this is a kind of the one class group. So we can say this is a class one, which belong to the female, and this is a class two, which belong to the male. Okay. So if I'm putting a new information, suppose I'm putting the n value which is lies on something over here. Okay. So at that time I need to identify what is the height of the particular person and what is the weight of the particular person. So based on the its new inputted height and weight, I need to predict where the information lies, and on which I can say, or on that point I can say I need to classify the new inputted data. From this point, let's add a new data point and figure out is it male and female. Okay, so from this point, we need to clarify our information and see this is data is given in the sample data, and here on the sampling data, we are producing something over here. So we have this information. So all these things are the assumptions based. So we are understanding the concept by the assumption based. Okay, so that's why we can understand what is mean by the SVM and properly and how SVM works. That is my point. Now tell me, this information is this made this clear to all, and just let me know. You can observe over here. We have the two different groups, two different class, and no different data points or no different data values are scattered from each other. They are just they are arranged into a group only. You can observe over here. Is it visible to all? Is it visible? Is it visible?
Yes, sir.
Okay. Suppose this is my point. Suppose I have given a new data. Let's add a new data point that's female and male. It's we need to generate. And suppose I'm just taking only example purpose, and its weight is approx 95. Okay, its weight is approx 95. I can assume over here, and its height is approx 169, something like this. We can assume even 68. Okay, so this is the information we have given, and we are plotting our information as a new data set over here. Can anyone tell me in which class the new data will be? It's a male or female? Don't think about the sign. Just tell me how to determine where is the this value lies. It's a male category or female category. Just tell me. Can anyone tell me if the image is not given, only data points are given or values are given? So by knowing the data values or data point values, can you easily justify this belong to the male class, this belong to the female class? This is my question. If you're saying that it is male, so how you can say? If you're saying it is female, then how you can say? Just let me know right now. This is my point. Just tell me. Speak fast. Can you imagine? Please tell me. Or can you find?
Sir, by checking the height and weight ratio.
Okay, so that is the point. Any other point?
Sir, it is closer to the male group
Okay,
appears to.
yes, that is a expected answer I was waiting. See, you will see the closest point. Okay, but the closest point we cannot easily determine. So we have some approach or we have some idea by which we can imagine. So if you're adding something over here to figure out if it's male or female, so we need to calculate each and everything properly, and those calculations are done by the some step by step. Let us start this point. Let us start this point, but before explaining this point, just let me give some idea over here, then you can understand. I am taking the new image for a betterment, then you can understand in simple way how we can identify is it the real thing or not. Just yes, this is my point. Suppose I am just dividing decision boundary. I am using a decision boundary to classify my data like this one. Okay, so this could be considered as a male. Okay, but I'm choosing another line for explaining purpose. Like suppose I'm choosing this line. This could be defined as a female. This could it can define as a female. This can be defined as a male. So everything is dependent on the decision boundary. Am I right? Everything is dependent on the decision boundary. Am I right? Based on the decision boundary, we can classify. Tell me. Based on the classification, we can do classification can be done by or classification can be completed by the decision boundary. Am I right? Just tell me yes or no.
Yes, sir.
Okay.
Yes,
So
sir.
if I'm yes, of course. If I'm choosing the M decision boundary, so we can say it is a male, and if I'm choosing F decision boundary, so I can say this is a female. Now we can say if this is a decision boundary, and our model will get confused at a time which boundary should be chosen as a classify the data. So at a time, SVM is saying to us, if you want to classify the data, then we have the different lines over here. It could be many lines, and that all those lines lies between the some points. At the time we have the multiple line. Then we will choose only the best line that splits our data, that splits our information into different categories. Let us understand by this example, as I told you, sure for this task we need to split our data. If I'm choosing this one, then we can say it is a female. Then if I'm choosing this one, then we can say it is a male. Like it can be male and it could be female. So depend on the decision boundary, or because it is a line. According to my statement, we can split our data by choosing any one of these lines. There is a line one, line two. Again, the my model get confused, or my model will ask me the question. Okay, I'm asking a question to my model. Which line I must choose as the best line? If I'm choosing line one, then if I'm choosing line one, then I my this new data will be considered as a male. If I'm choosing line two, so my new data will be considered as a female. Okay. Till now, this concept is clear. Please tell me. Till now, this concept is clear.
Yes, sir.
Okay. Now,
Sir, can you repeat again? I got
okay,
disconnected actually.
okay, no problem. See, I'm saying here, if you are dividing, you are using decision boundary to decide the classify the data. If you want to classify the data by line 1, then your new input data will be as a male gender. And if you're choosing the line 2 to classify the data to different part, then at the time your new input data will be considered as a female gender. That is the my point. But at the time we have the question, here we have the question, now this person will get confused here right now, which is the best line I must use. This is the point, which is the best line. Is the best line. So best line will be decided by the some approach, and that approach we will see over here. That is my point. So can anyone tell me which line I must choose? Yes, please tell me. Which line I must choose? Please tell me. Anyone who have any idea? Please tell me right now. Which line I must use? Yes, please tell me.
Line 1.
Okay, why line 1?
Because it more appropriately divides both the data sets, data
Yes,
points.
yes, I can agree with I can agree with your point, but why you are not choosing line 2? It is
Because
also
line 2 is like some of the data points of male class are lying on line 2.
yes, that is the point, and that can be identified by some concept we will see over here. Yes, of course, you are on the right track. So that is the next slide is saying to us if you're choosing, okay, we need to if I'm choosing line 1 to predict the our gender, the new input data that could be male or female. So we will that's why we are choosing the best possible line. So line 1 is saying to us different way, line 2 is saying to line 2 will say two different concepts. Line 1 I am choosing right now. I am choosing the line 1 as a best splitting data. Now, questions we have in our mind, or the student, the person is asking again, why do you say it's the best split type? So let me prove this statement. If I'm choosing the line ones, let me give some proof over here to justify my statement why I have chosen the line one. See, if I'm choosing the line one over here, now the line will be drawn over here in linear way. Okay, that a point you need to keep in mind. Line will be drawn over here in the linear way. Okay. So if I'm choosing a line one, so my data automatically will be in form of the male category. As a user, I can see, but my machine will not easily determine. So I need to justify. I need to give some more proof to give my model that is the line one why I have chosen. If I'm choosing line one as a best splitting line, this is my point. So after choosing the line one, this line is known as a hyperline. Okay, why? Because I need to draw some other different line and which are close to the and those are known as the dashed line, and that is touching to the two different data points of the respectively class. So I have circled over here which describe the maximum space between the two separate classes. So if I need to choose how to define the maximum space, so you can see this is the point. Okay, this is the point which is this is a data point. I can consider this a data point. This is a data point. I need to draw a line respective to this line over here and in the dash format, dash manner, and I need to draw another line with respect to this data point, which is a female data point, female gender data point. So after designing or drawing these two lines, if I need to consider the space, and this space is known as the maximum space. So if you want to maximum space on which you can decide is the line one why I'm choosing because only the one factor that is the maximum space. So maximum space should be more. That is the point you need to keep in mind. So this line will basically has a maximum space that's separated to two classes. And this data set is just I can write this these data points actually I can write over here data points these data points are closest are the closest to line one. Okay, You can see over here. Now it is visible to all. Now it is visible. These are the two data points which are closest to the line. Now is it clear? Now after drawing the line, we need to calculate the maximum space. So we are getting the maximum space. Now you can see. Now this is visible to all. Just tell me, is it
Yes,
visible?
sir.
Yes. Okay.
Yes, sir.
Yes. Okay, good. So now, if I'm jumping to the next slide to explain my next idea about the more detail over here. Okay, this is done. I have done with the line one, but it is my responsibility if we have the multiple lines. I need to check the all those lines. So I'm just using line right now, the line two to check it contains the maximum space or not. So you can observe over here the maximum space of the line 1 is more than the line 2. Okay, so while the other line, that is line 2, does not have the maximum space, so that's why we can say we have chosen the line 1. Okay, so now this point is clear why we have chosen the line 1. Tell me, this point is clear. Tell me now, this point is clear why we have chosen line 1.
Yes, sir.
Okay, so as a user, we can say this data point belong to the male category or male gender. But all the information are stored into the computer in the form of the computation space, the number space. So how the number can be interpreted? So either some mathematical are required, and those are known as the some more technical terms by which we can easily identify by the some idea that is the which class, which new input data belong to the which class. So here we have chosen our line, and this line is known as the hyperline, and that line is also known as the distance boundary. Okay, this is the point you need to keep in mind. Now, this look like this one. So that's why we have split our data into two different parts, following by the best selected line. Now, after understanding this point, we have some theoretical part over here. So right now, what are the those terms we are required to keep in mind for the coming slide? So let me explain over here. Support vectors. Support vector means data points that are closest to the hyperplane is called the support vector, and that is the reason this model is known as the support vector machine. So in the machine learning, we are using the support vectors approach to solve our problem to classify the information. So that's why it is known as support vector. But what are support vector? Support vector means data points that are closest to the hyperplane. So from this image, you can able to see over here these two these two these two values, these two data points, which are displaying over here, which is marked by me into circle, then you can see these are the support vectors. Okay. Now this part is clear right now. What are the data support vectors? This part is clear. Now let me know this point is clear. What are the support vector? Okay, tell me.
Yes, sir.
Okay, good. So this is the point. Now next one we are talking about the hyperplane. So what is mean by the hyperplane? So in the hyperplane, as you can see in the previous diagram, it is a distant plane. You will see. Okay, you will see. See, this is line one. Line one is also known as the hyperplane. So it is a distant plane, or we can say it is a distant boundary or where space and which is divided between the set of the objects having the different classes. So here we have the two different classes, male class and female class, and margin. Margin is also known as the distance margin, and it may be defined as a gap between the two lines on the closest data point you need to keep in mind. And that margin can be identified by the D1 plus, oh sorry, D1 plus and D minus. Okay, we will see. So the different classes, and it can be calculated as a perpendicular distance from the line to the support vector. I am repeating the once again the statement. Please keep in mind the statement you need to keep in mind. It can be calculated as a perpendicular distance from the line to the support vector. So in the diagram you will see, and large margin we consider as a good margin, and the small margin we consider as a bad margin. Because if you have the very minimum margin, then your model will not classify your data properly because you don't have a good margin. So you must have a good margin. Good margin means the distance we must have maximum. Okay, that is the point we need to keep in mind. So that's why we have chosen the line 1 because it is considered the maximum space. But line 2 does not contain the maximum space. That's why we have discarded line 2. Now we have some animated form of the image in which you can see number of iterations going on, and the process will be go into iteration multiple times. Line 1, line 2. Suppose we have the number of the n lines, so we need to just step to choose the. Okay, I can write over here to choose hyperplane, or we can say hyperplane, or we can say or best line. Iterative process will go on. Iterative process will go on to decide what is decide best line. So now you can see over here, see everything you can see over here in the two different diagrams, all the green and red are the support vectors, but these are not closest support vector. So which one is closest support vector? You can observe over here, this is the closest support vector. There's a closest support vector, okay, where it is lying, following by the maximum distance. Now we have that this is would be your closest vector over here in the green. This is the closest vector, and this will be considered as a closest vector. Here we have these three are the closest vector you can consider, and this would be as a closest vector. Okay, so maximum you can. So you need to choose the hyperplane properly. Now come to the our example, then you can understand here. So what is the point? Let me add some technical terms over here to explain my idea in more way. And that is the point you need to keep in mind. Important I have written over here. We can also say that the distance between the point and the line should be far possible. Why? Because you can say now you have the good margin, and due to this reason you can classify the information properly. So here we have the new data, and this is known as the distance margin, and this is known as the line, and it is known as the line 1 over here, and this is a data point. Now, this is a normal term we have over here. Now, is it clear right now? Is it clear?
Yes, sir.
Okay. Any doubt? Student, please tell me right now. You have any doubt? Because technically we need to understand some terms which are required to understand the SVM, the support vector machine, how support vector machine is working. I'm explaining over here with the help of the images. Okay, so new data will be as it is on the some line, but we need to prove this point. Okay, so that's why I'm just using the appropriate terms. Now, after moving to the next slide, what the point we need to keep in mind? This line we can say line 1, or the line it is mentioned was into the previous slide. That is a hyper. Okay, this is line 1. I can say okay, and that is a hyperplane. And this data point which are closest to the our line, that is known as the support vector, and this is also data point of the male and female respectively. Here we can over here. That is my point. So in the technical term, we can say, okay, we can say, of course, the distance between the support vector and hyperplane should be as far as possible, as I told you. So a model which support the support vector in ML, that is why the name given here, the support vector machine. Now, this term is clear right now, where the SVM term is coming in the machine learning. Now, this term is clear. The fundamental part of the support vector machine, how the support vector machine name is coming from. So, is it clear right now? Please tell me. Is it clear?
Yes, sir.
Okay. After understanding this point, where the support vector machine terms coming from in our model, and what is the function is going on, so we will try to understand. Now, still we have not decided. That is the new inputted value or new data will be the male or female. But we are just trying to find the hyperplane or good hyperplane. Okay, that is my point. Following by the good margin. Okay, so next slide is saying to us line of the male data points. Of course, this point we have already discussed. See, this line, that is dotted line, belong to the male data point line because it is touching to the this support vector, and this line support to the female one, and this line belong to the male one. Okay, that is the point we need to keep in mind. So no need to discuss more over here, but we need to keep in mind We are choosing only, or we're drawing the dot that is just those lines which are touching to the, which are closest to the, our data points of the classes. So we have seen already this concept by the animated way. Now the hyperplane has the maximum distance to the support vector of any classes. That is the task we have done. That is a my point. So far you have any doubt right now? Tell me what is mean by the hyperplane, what is mean by the support vector, what is the distance margin, and what is the maximum space. Now tell me, everything is clear right now? These technical terms are clear to all?
Sir, can you please repeat the hyperplane?
See, okay, good. Hyperplane is basically what? Hyperplane is basically, just let me explain by this definition, then you can understand properly. This is the term, and you can understand. What is mean by the hyperplane is written over here. It is a distinct plane or the space which is divided between the set of the objects by the different classes. Now, this point is clear right now. The definition point is clear to all right now. Hyperplane. Definition point is clear.
Yes, sir.
Okay. Okay. So I'm just coming back over here. Now this term. Now you can see here. I'm just drawing over here for explaining purpose. Suppose we have this group, this data, and we have some data over here like in star wave. Okay, this point. So there will be, yes, there will be a line which are touching to this data point. This data point is known as the support vector of this class 1. So I can write the C1 class is support vector of the class 1. And this is a data point if we are if you're drawing a line, okay, so we must use a line over here, and the line should be, or this margin should be the margin. What is the meaning of the margin? So please note down this important one. Margin is basically saying, and it is can be calculated as a perpendicular distance from the line to the support vector. It means we can't take any line like this one. Okay, why? Because line it is calculated as a perpendicular way. So I need to use properly. So just let me use. Yeah. So I just need to draw the line in the perpendicular way. So that is, it can touch to this one, or it can touch to this one. So this could be the two support vector. We will choose only the, or we can say that these are the support vector. Okay. So this is the hyperplane, and that is our line which describe or which adjust your this dotted line for the margin purpose. And the distance between these point to over here, that is known as the distance margin or maximum space. We have the maximum space and more maximum space, then we can classify the data in appropriate way, because we have the long distance between the two different kind of the data of the classes. That is my point. So hyperplane is what this which describes the distance between the two different classes. So that is an important point we need to understand. This line describes the separation of the, or this line describes the separation between the two different classes. This is separation of the class C1, class C2, and the separation of the class C. Okay, and these are can be identified by the support vectors. This is a mark. Now is it clear? And this process is not a one-time process. It takes many steps to get the appropriate or best hyperplane or best line. So now over the slide you can see some animated way we are expecting something. Now see here, see in this image number 1, I'm showing over here. It is starting from the very minimum far and then expanding its distance by covering the hyperplane adjustment followed by the perpendicular planar. So now finally we got the good distance. Same thing it is happening over here, and iteration is done by the 1,40,000 so and so, and it's moving around the 7,60,000. So iteration will be starting from the 2000 point. That is the my point. Now this hyperplane is clear right now?
Yes, sir.
Okay, so hyperplane is basically the plane, or we can space which divide the data into two separate portions. After understanding this point, as I told you, what does it mean? Okay, so we were on this point. As I told you, the hyperplane has the maximum distance to the support vector of the class. And after this point, what you can get or what you need to get, this is your distance you need to calculate. So from this hyperplane to this point, from this hyperplane line to this point, you are calculating. From this point to this point, you are calculating. So this distance is why we are choosing this distance, because this data point is closest to the hyperplane. This data point which is marked over here, just let me use this one. The data point which is displayed by the red color in the male group, and that data point is closest to the hyperpoint. So the distance between this data point to hyperplane is known as the closest distance, and that is identified by as a positive distance because it is too closest, and that is identified by as a D1, also D plus. Okay, is it clear right now? This term is clear. What is mean by the D plus? D plus is the positive distance point from the support vector. Okay, now this point is clear. And after understanding this point, I mean to say over here, D plus is the shortest distance to the closest positive point. Okay, so you can observe over here. Now this is clear to all right now. Tell me, is it clear?
Yes, sir.
So this distance is covering from the closest distance. Okay, and if I need to move next part to describe the D minus. So D minus is what? D minus is the shortest distance to the closest negative point. So this distance you can observe over here, and this distance if I'm taking from the hyperplane to this distance, then it is what? It is not closest distance to the closest distance. It is not close to the our information. So that is following by the shortest distance to the closest negative point. So we can say it is a negative point. Now you can observe over here the distance from here and the distance from here. Which one? This is the closest distance. Okay, this is the closest distance. I can write over here. This is the closest distance for your betterment. So the shortest distance between hyperplane and the support vector, that is D plus or D minus we can say, but that is identifies the negative data point and negative point and positive point. So if I'm doing summation of the, if I'm trying to do summation of the D plus and D minus, suppose I'm doing the summation of the D plus and D minus. If I'm trying to do some D plus and D minus, what I can get? I can get the same value as a maximum space, or I can say distance margin. This would be equivalent to the distance margin. Okay, so this would be the distance margin. It is written over here. Sum of the D plus and D minus is called the distance margin. So distance margin equivalent to the maximum space. We can consider distance margin or this what we have maximum space. Both are having the same sense. No problem. Okay, so this is the various technical terms we have described. What is mean by the hyperplane? What is mean by the distance margin? What is the maximum space? What is the D plus? What is the D minus? And what is the support vector? Now till now, this point is clear to all right now. Tell me, this point is clear?
Yes, sir.
Okay. Anything you are having any doubt? Please, you can ask me right now. So practically, if I'm saying to here, the support vector machine, in a support vector machine, having seen the value, having seen the object, we will not decide it is this new input data will not go this class or this class. We need to calculate each and everything. We need to determine the appropriate way to define the each and everything properly, and that's why on that parameter, the everything will be pictured. So support vector machine is saying to us we need to do each and everything. So here we have taken the real example only for understanding purpose, but we will not fit the values. All the values of data point will contain some values. Okay, that is the point. But how the interpretation can be done insidely by the our algorithm. So that is the functionality we are understanding. Okay, so that is the my point. After understanding this point, we have a question right now. From this distance margin, we can get the optimal hyperplane. So we have chosen, and that is our optimal hyperplane. So that is no problem. So what would be our aim under the support vector machine? Our aim should be to get the optimized or optimal hyperplane. After getting this problem, now we can say now we can easily determine based on the hyperplane. The what you need to keep in mind based on the hyperplane and why we have decided the high distance margin, why we have decided the d plus d negative, why we have decided the hyperplane, and why we have decided the support vector to get the optimal hyperplane. Okay, and that is known as the selecting the best line. Based on the hyperplane, we are putting the new information. Now we are putting the new information. Maybe we are putting the new information at this point. Okay, so now we can decide this data belong to the female class or female category. If I'm putting the new data over here, like I can over here, I just draw the some stars over here, then you can understand. So we can easily determine this data belong to the male category. So our objective and the supervised support vector machine under supervised learning is saying to us, you need to decide the best hyperplane. And based on this hyperplane, we can say the new data was the male gender. So now we got our answer. So everything is clear right now. So we got our answer. That is our objective is clear. Now new input data was the gender. That is the male gender. Now this point is clear right now. Right now the point is clear. Tell me.
Yes, sir.
Okay, so this is just idea about the what is the support vector machine by taking example of the to decide or to predict the gender of the person, newly inputted person, that is a male or female. That is my point. But again, we have so many questions. What if the hyperplane is not optimal? How to decide the hyperplane is optimal? Like this one. If you select the hyperplane having the low margin, then there is a high chance of the misclassification. Now, this kind of the hyperplane we are choosing, definitely what we are doing, we are doing the misclassification. It means we are not categorize our data in a proper way. In appropriate way, we are not we are not classifying the data in proper way. So this hyperplane, we can say it is not optimized. Just like we have seen over the slide, just let me to maximize zoom mode, then you can understand now. So at the time, this hyperplane will not decide our data in appropriate way. And that is a point we need to keep in mind. But so far, we have seen the problem, and that problem under come into the Lagrangian support vector machine. Basically, it is a fast technique. Basically, it is a flavor of the SVM. Okay, LSVM is also sometimes known as a low or a linear support vector machine. But technically, the name was or name is over here. We have the Lagrangian support vector machine. It is basically a fast technique for the training the model by the support vector machine. That is a point we need to keep in mind, and that is also use the iterative approach. As you have seen the various two animated images, we have the iterative process and iterative approach. The iterative approaches we have done receptivity. So by default, this example is under into the our flavor of the SVM, that is known as the Lagrangian support vector machine. By default, the support vector machine we have almost it is followed by the only this kind of the flavor. But here we can say this can be considered as a low support vector machine or high support vector machine. High support vector machine always recommended the maximum spaces, but they will not say HSVM. So what is the done? We have the next step. In the next step, what we need to do? We need to understand what is mean by the linear SVM or non-linear SVM. So that is a more generalized term, and that is a more important term by which we can understand so many things. But so far we have discussed about the SVM that is undercome into the default SVM that is also known as the Lagrangian support vector machine. Now, But still, the question we have to understand that is the point, understanding the support vector machine. So far, we have seen what is meant by the support vector machine and why support vector machine is required. Next, we have the step understanding support vector machine. Before moving to this point, we will cover this point within 10 minutes. But let me know if do you have any problem so far. We have seen or we have discussed various terms, various understanding of the support vector machine under the supervised learning. Yes, please tell me. Any student who have any doubt? Yes, student, tell me any doubt you have. Please, you can ask me right now.
No, sir, no doubt.
Okay, so I'm going to start this important sub point of this topic, that is the understanding support vector machine inside the introduction to the support vector machine. Now, here we have this kind of data. Now, what does it mean by? Can anyone tell me what does it mean by this kind of data? Now, tell me, can you differentiate these two kind of the data? Of course, we can do. This is sample data set we have worked over here, and this data is we have in the non-linear way. So we can say this is a non-linear data set. You can write over here, this is a non-linear data set. Can I say this is non-linear data set or data point? Can I say this is a non-linear data point? Please tell me. Say yes or no. Yes, friend, tell me. Can I say this is a non-linear data point or no? Just say yes or no something.
Yes, sir. Yes.
Okay, so if these are the non-linear data point, then you can decide hyperplane like this one. Okay, you can decide another hyperplane like this one. You can decide another hyperplane like this one, and just maybe you can take this one. Okay, so at a time in the non-linear data point, we can decide the hyperplane. We can do no issue. There's no issue. But when talking about the this point where we have linear data point, in the linear data point, then in the linear data point, then how you can decide the hyperplane? That is my point. Can anyone tell me how we can decide the hyperplane on the linear data point? Just tell me how to. Yes, please speak. How to decide hyperplane? Just tell me how to decide the hyperplane over here. This point is described to over here. If we're talking about the understanding the SVM, then SVM cannot be understood by simple way when we have the linear data point. And to resolve this problem, we have the kernel function. Okay, and that is saying to us, we need to transform our one-dimensional data set into the two-dimensional data point. See, by default, the non-linear data point can be recognized as a two-dimensional data point, but the linear data point can be identified by as a one-dimensional data point. So we cannot use the hyperplane on the linear data point. At that time, we need the transformation. Let us see. So here we have the linear data points, and those are recognized by a one-dimension data point. So it is necessary to transform one-dimensional data point into the two-dimensional data point view. So hyperplane can be applied over here. At a time, a function is required, and that is known as the kernel function. The kernel function basically used to transform your one-dimensional data set or data point into the two-dimensional data point. Okay, so that is the point we need to keep in mind. Input will be given as a two-dimension, and output will be as a two-dimension. Over this slide, you can see. So that is important one. We need to keep in mind kernel function. And kernel function in more detail I will tell you in the next class. Don't worry. But let us understand in simple way what is meant by the kernel function. Kernel function is a function which transform your one dimension data form into the another dimension of the data form, and that is necessary on which hyperplane can be applied. Now, this point is clear right now. Tell me, this point is clear. What is mean by the kernel function? Please tell me. This point is clear. What is
Yes,
mean by?
sir.
Okay, good. So you can observe over here, we got the result. You can see all the data points are now divided, all the data points are plotting over here. Now my equations that was a 1D of a linear way transform into the non-linear way. So equation we can write the y equal to s here. So at the time I can apply the hyperplane or my line. So over the 2D we can see or we can display. That is the beauty of the kernel function. So SVM also require the kernel function when we have that some data point into a different way, and when hyperplane is not applicable, when hyperplane on our data point is not applicable, then kernel play important. That is the when hyperplane is applicable in easy way, so no need to use the kernel function. But when this approach is not possible, then we need to use the kernel function. Now, how to perform the SVM for this type of the data set that is non-linear we have in the 2D as well. Now tell me, if I'm using the three different lines for the hyperplane, line 1, it's not possible, line 2 is not possible, line 3 I'm using. Again, I'm unable to use this data set to use into the my SVM. At the time, how I can solve this problem? Can anyone tell me? Can anyone tell me how I can solve this problem? Just tell me. Just tell me here right now. Please speak fast. How I can use?
No idea, sir.
It's very simple, my dear. As I told you, in the kernel function, basically used to transform one data set into the another data set. So if we have the here non-linear 2D data set, then we can transform it into the 4-dimension, oh sorry, 3-dimension data set, like this one. Okay, so that is not possible. Like this one, we can transform. Now you can see over here. Now you can see over here. Now it is visible. Just tell me, it is visible. Just tell me, it is visible or not.
Yes, sir.
So what we
Yes,
are
sir.
okay. So what we are doing, we are transforming 2-dimension data set into the 3-dimension data set, and this line is showing to us. This line is saying to us the line is saying to us the hyperplane in the some rectangular way you can able to see in the 3-dimension, and that is the beauty of the this part. Okay, that is my point. So, okay, student, now tell me any doubt over here. Please tell me any doubt you are having. Please, you can ask me right now. Student, tell me any doubt you are having. Please, you can ask me right now.
No, sir.
Okay, good. So, if we're talking about the summary of the today lecture, then you will able to see the important point over here. See, I was on the point this is your hyperplane. Okay, this is your hyperplane. Hyperplane, and you can note down the important word over here. This transformation can be done by the kernel function. So what we have seen today in the class, in the Y support vector machine, we have seen the classification and decoration will be applicable in the support vector machine. And what is support vector machine? In this point, we have seen the hyperplane, that is also line, maximum space, that is distance margin, support vector. We have seen each and everything technical term as well. For help of some example, an example, as we have seen the to represent the gender. And understanding support vector machine is saying to us, we have seen the kernel function, and that is important when we have the data in the that is not applicable to the hyperplane. So when we need to use the hyperplane, at the time the kernel function is required in our data.